everyone. It's amazing to be here with you all today.
Yeah, it's great to be doing this together, Angela. And what a crazy ride we have had since we started building Llamas together.
Yeah, when we started making Llama 4, we reflected a ton on the feedback from you all in the developer community on things like new capabilities we should add, improvements that we wanted to make, and we heard things from multimodal support to increased efficiency in the base model.
We couldn't take an incremental approach to Llama 3. We had to take a step back and look at some hard technical decisions we had to make for Llama 4, and each one came with different trade-offs.
A really early one that I remember we debated was just the architecture itself. We had been working a lot on dense models. We had a lot of experience with this. It was simpler and to configure, easier to parallelize, but should we make the jump to sparse?
And Llama 3 model family was dense, and we knew dense had its drawbacks, and we had to think about alternate architectures.
Yeah, exactly. Dense models, they can be really compute inefficient, and as we train more and more models and develop more products, a lot of this training inefficiency hit us pretty hard. And so we ended up going with sparse. There was, of course, all that added complexity in some of our deployment and our training, but we got a lot of wins in performance, efficiency, and cost.
I also remember the technical bet we made on distillation. Llama 4 Behemoth was a 2 trillion parameter model, which packed a lot of intelligence, but it is harder to run at scale. So we used it as a powerful teacher to improve the performance of Maverick at the same price.
Another one that I remember is incorporating multimodal, right? Early or late fusion was a discussion we had. So when we first started taking Llama 2 and trying to expand out of the text performance of that towards Llama 3 by adding the image capability, we had kind of frozen the text model of Llama 3 and added on image by adding adapter layers. This was very straightforward, and it made for a very modular system.
But with Llama 4, we wanted it to be natively multimodal. So we took a step back and changed the training recipe. We started with text training, interleaved other modalities, and this allowed Llama 4 to be cross-model training, which made both Scout and Maverick much better across all modalities. I think we can keep going on and on the numerous technical decisions we made in building Llama 4. But we are excited today to talk about the API. Our goal from the beginning for Llama 4 API has been it should be the fastest and easiest way to build with Llama. Not only that, as you saw, the derivative models, it should be the best way to customize these models. And going one step further, you should be able to take these custom models with you wherever you want. No lock-in ever. Speed, ease of use, customization, and no lock-in are the marquee features of the Llama API.
And we handle all of the inference and the infrastructure work, so you all can focus on building your products, what you care the most about. We want to deliver the best performance and the features that you would get using closed model APIs, but with the control and the openness that only the open source ecosystem can provide. Let's check out how it looks right now. So if you want to start, you can just register your API key with one click. If you're ready to go right away, you can head on immediately make a curl request. Just copy the code, head to the command line. We maintain a lightweight Llama API SDK in both Python and TypeScript. Or if you're already familiar with the OpenAI SDK, you can use that directly by just adjusting the endpoint. This makes it really easy to migrate applications to Llama. If you want to just play around quickly, you can head on over to the chat completion playground, where you can play around with different models, test it out. You can change model settings, like the system instruction or the temperature, to test out different configurations. Llama 4 models are also the leading multimodal LLMs in their class. You can take advantage of this image input as well, and you can also send multiple images per prompt. If you want a structured response, you can also input a JSON schema to the model. You may also want to use tool calling. We allow you to provide tool specifications so that the model can decide when to invoke them autonomously. And this is a preview feature that we're looking to get a lot of feedback from the developer community so that we can also improve. Once you're done configuring and setting up everything, you can hit Get Code and copy from there right into your code base. And we've designed all of this with a focus on data privacy and security. Any input that you send to the API or output that you generate, we don't use to train our models.
Those are the basics. But as we talked, customization is where open source should really lead the way. And one of the ways to customize these models is fine-tuning them. The Llama API is really good at fine-tuning for your product use cases. And the best part, you have full agency over these custom models. You control them in a way that's not possible with other offerings. Whatever model you customize is yours to take wherever you want, not locked on our servers. This opens up a lot of possibilities for people that need to build and deploy custom models. Here is a quick way of fine-tuning, how fine-tuning works. You can click on the fine-tuning tab. Once you are there, you start a new job, and you upload data that is used for your fine-tuning. Or you can reuse the data that you have already uploaded. By the way, you have new synthetic data toolkits that help you generate really good post-training data for your use case. We talked about this with the Llama 3, 4, or 5B model as a distillation mechanism. There's a dev session later today if you want to learn more about it. Once your data is uploaded, a typical thing you could do is splice some part of the data for evaluation so you know how the custom model is going to do. And you configure the job, giving it a name, choosing some hyperparameters, and it's that simple. You can keep an eye on how the job is progressing, where you can look at the training loss as it progresses in real time. Once the job is complete, you get to the best part. You can go and download your custom model and run with it wherever you want. You're not locked in. Or you can run it on the Llama API, whatever is convenient for you.
OK, so you fine-tuned the model. Now you've got it ready. But how does it actually perform? So to evaluate your fine-tuned model, you head on over to our evaluation area. We fill out some of the boilerplate for you, like the job name and the model. And if you've split your data set during the fine-tuning process, we also select that by default. More importantly, you can add one or more graders that will score your model's outputs against specific criteria that you care about. For example, maybe you really care about the factuality capability. From there, you can kick off your job. It then hits our batch inference API, and we generate a bunch of model outputs and grades them. When the evaluation job is complete, you can check out a quick summary of your graders, or more importantly, you can dive deeper into the results and read them yourself. I feel like with text generation today, you just can't replace reading all of the content. Our flow is designed to be very simple compared to alternatives, which will help you understand the performance of your fine-tuned model as easily as possible.
Many startups have been testing the Llama API for a while. The early feedback we're getting is how easy it is to use, the speed and quality of responses. So that's how you build your own llamas using the Llama API, available for preview today. But wait a second. This is only one part of the job. The second part is actually taking these custom models and running them at scale, which brings us to your favorite topic, inference.
Mono knows me too well. I mean, you've built all of these great models, but how do we actually serve them efficiently? And so when we designed Llama 4, it was with inference efficiency in mind. This is a huge priority for Meta, because Maverick powers Meta AI, and we have users all over the globe. And it's also extremely important that we've heard from all of you in the developer community. We use the mixture of experts architecture to activate only a fraction of the total number of overall model parameters. But beyond this MOE design choice, we specifically sized Maverick, why is it the number of parameters it is, to fit on a single host with FP8 weight quantization. This makes deployment very straightforward, because you can use single host inference. Although, of course, if you want higher throughput, distributed inference options are always available.
And the Llama 4 Scout model fits on a single H100, which really opens up many more possibilities for the developers. OK, so that was the model. We should also talk about the inference stack.
Yes. So we can't forget about the software we serve on. So as we moved from dense to MOE, we actually switched over to our brand new MOE runtime to power this inference stack. And we shipped a couple new features along with it. For example, we added speculative decoding. This is a technique that uses a smaller model to draft a set of tokens for the main model to use. And it will speed up token generation by about 1.5 to 2.5x. We also use paged KV to handle long queries. This breaks up the KV cache into multiple smaller blocks that can be more efficiently stored and accessed with a lookup table from a memory management standpoint. And of course, being an open model means that hardware makers can do deep integrations to deliver the best performance that you'll get anywhere. We're thrilled today to announce a collaboration with Cerebras and Grok that will help developers get even faster inference speeds with the Llama API. You can now request early experimental access to Llama 4 models powered by this exciting hardware, which is a great way to experiment and prototype with different use cases before scaling with a vendor. And to activate this, you can just select Cerebras or Grok, those model names in the API, and you'll be able to test them out and have a streamlined experience straight out of the box.
So those are the partnerships. This is what you've got to work with: the models, the API, and the Llama ecosystem of partners. The speed and the efficiency, the ability to ship by building really robust products on top of really robust infrastructure, and the power to customize the models and take them with you with full control over what you build. When you put the models, the API, and the Llama ecosystem of partners together, you can do incredible things. And we are already seeing this happen with agents that can navigate the web and use computers, with state-of-the-art performance on open source, on OCR, with open source models built on top of Llama. They are showing up every day, and it's just less than a month in. There's never been a better time to shift to open source from closed models. You get maximum flexibility, full control, and the freedom to build wherever and however it makes sense to you. It's a great time to build with Llama. And thank you so much for joining us. We can't wait to see what you build with Llama 4 and the API. Back to Chris.